The brain is the only thing in the universe that presumes to study itself, at least the only thing that we're aware of. And one of the areas that it's particularly bad at studying is how cancers grow in the brain and where they come from. We are developing a program, and it has been enormously supported and helped by some of the generosity from our philanthropic donors around three areas. One area is understanding how these cancers grow. Another area is understanding how we can improve our treatments for these cancers. And the third area is understanding how we can support and help patients in their journey to learn how to cope with these cancers and to deal with all the stresses that come with the treatment. How these cancers grow is an interesting one, and we don't really understand it very well, I'll be honest with you. By the time brain cancer presents itself clinically, either through a seizure or through changes in behavior or through apparently having a stroke-like weakness or something like that, it's quite advanced. And that is one of the challenges. So if you imagine the Earth when the dinosaurs roamed the planet, and our treatments are like the meteorite that hits the Earth, wipes out the dinosaurs. And all that does is clear a pathway for these previously unseen animals, the mammals scurrying around in the undergrowth, these stem cells, these cancer promoting cells. It gives them space to take over. And they grow and they spread, and then they dominate and drive the tumor. And some of our work is related to understanding how that driver domination develops and how these different cell populations, like animals on Earth, fight for resources and compete to outdo each other and grow. We're doing that at the moment primarily from the perspective of tumors that arise de novo from the brain. But increasingly, we're interested in tumors that spread to the brain from elsewhere. And our top three are lung cancer, breast cancer, and skin cancer. They're the commonest ones. In addition to that, we're also running something called the Tessa-Joule brain matrix. It's named after Baroness Tessa-Joule, who herself died of a primary brain tumor called a glioblastoma. These are the commonest and most aggressive brain tumors. And she gave a fantastic rousing speech in the House of Lords, where she asked for effort to promote hope so that every patient is looked after while the scientists work hard to try and develop new treatments. Within the brain matrix, we are looking to develop new treatments and get them to patients. We're also looking to capture all the data, the imaging data, the clinical data, and the biological data, including the genetics data that you've heard about already from Professor Beggs. And that trial has now started, the platform trial has started, beginning to develop that infrastructure to get genetic and imaging information back to help patients treat patients better, to help clinicians treat patients better. And lastly, but by no means least, we're working on research to try and help the patient in the here and now, to help them cope with the journey, to understand what things matter to patients, whether it's managing seizures, coping with the side effects of drugs, or coming to terms with the inevitable end, which is the recognition that we're all mortal. So those are the three areas that we're interested in. It covers a holistic approach, and we're building a fantastic team